What if I told you that right now, somewhere in our galaxy, there is a place where the laws of physics completely break down, a place where time itself stops, where light cannot escape, where everything we know about reality just ends. We call it a black hole. And for decades, scientists, physicists, even Einstein himself, they all agreed on one terrifying thing: whatever goes inside a black hole is gone forever, lost to the universe. No information, no signal, nothing. But in 2024 and 2025, something changed. Scientists didn't just study black holes from the outside this time. They went deeper, theoretically, mathematically, computationally, than any human mind had ever gone before. And what they found will genuinely shake you. Let me take you back. 1916. Albert Einstein had just published his general theory of relativity, and buried inside those equations was something he didn't fully believe himself. A solution appeared, discovered by a German physicist named Carl Schwarzschild, that predicted a point in space where gravity becomes so strong, so absolutely overwhelming, that not even light can escape it. Einstein looked at those numbers and said, "No, this can't be real. This is just a mathematical trick. Nature wouldn't allow something this extreme." He was wrong. Over the next 50 years, astronomers began finding evidence. Stars orbiting invisible objects at speeds that made no sense. Gas clouds being ripped apart by something they couldn't see. And then, 2019, humanity did something absolutely historic. The Event Horizon Telescope, a network of radio dishes spread across the entire planet, working as one giant telescope the size of Earth, captured the very first actual image of a black hole. For the first time in human history, we saw one. M87, a supermassive black hole, 6.5 billion times the mass of our sun, 55 million light years away. And there it was, a glowing ring of fire around an endless darkness. The internet broke. Scientists cried, and a new era began. Okay, so what actually is a black hole? I want to explain this in a way that actually sticks. Imagine you take the sun, our entire sun, all of it, and you squeeze it. Keep squeezing. Make it smaller and smaller and smaller until it's compressed into a ball about 6 kilometers wide. That's roughly the size of a city. At that point, something catastrophic happens. The gravity becomes so extreme that space itself curves around that object completely, wraps around it like a blanket pulled too tight, and anything that crosses a certain invisible boundary, called the event horizon, can never come back. Not a rocket, not a laser, not information, not time, nothing. The event horizon is not a physical surface you'd bump into. You'd cross it without even knowing. But the moment you do, your future only points in one direction: inward, toward the singularity. The singularity, that word alone should give you chills. It's the point at the center of a black hole where all the math we use to describe the universe, it breaks completely. Equations return infinite values. Physics gives up. It's the place where our understanding of reality ends. Now, here's where it gets really interesting. Here's what scientists just figured out, and why this changes everything. For years, the biggest unsolved mystery in physics wasn't, do black holes exist? We know they do. The mystery was, what happens to information inside? Think about it this way. If you burn a book, technically the information isn't gone. It's transformed into smoke, ash, heat. If you could somehow capture every single particle, every photon of light, in theory you could reverse it and reconstruct the original book. Information is conserved. That's a fundamental law of physics. But black holes seem to violate this. Whatever falls in, a person, a planet, a book, a star, it's gone. And when the black hole eventually evaporates over trillions of years, the radiation it releases, called Hawking radiation, seemed to carry no information, just random noise. This created what physicists called the information paradox, and it was a war. Stephen Hawking on one side, saying information is destroyed. Other physicists on the other side, saying that's impossible. It would break quantum mechanics. Hawking famously lost that bet, but nobody could prove how information escaped. Until now. Recent theoretical breakthroughs, building on work from quantum gravity researchers, string theorists, and a concept called the holographic principle, have shown something remarkable. The information is not destroyed inside a black hole. Instead, it gets encoded. imprinted, like a hologram, onto the surface of the event horizon itself. The two-dimensional boundary of the black hole stores the complete three-dimensional information of everything that fell in. Think about what that means. You, a human being, if you fell into a black hole, your entire existence, every memory, every atom, every thought you ever had, it doesn't vanish. It gets written onto the surface of the event horizon in a language made of quantum information. You're not destroyed, you're archived. And the Hawking radiation that slowly leaks out over billions of years? Scientists now believe it's not random at all. It carries subtle quantum correlations, encoded information that in theory could be decoded. You could, in principle, reconstruct what fell in. The black hole isn't a grave. It's a hard drive. But what about the inside? What's actually in there, beyond the event horizon? The honest answer is, we don't fully know. And that honesty is actually part of what makes science beautiful. What we do know is that once you cross the event horizon, if the black hole is large enough, you might not immediately feel anything dramatic. No wall, no fire, just space. But warped space. Space where the direction toward the singularity becomes your only possible future. Like how you can't stop moving forward in time right now, inside a massive black hole, you can't stop moving toward the center. Time and space switch roles. It's not that you can't escape the singularity. It's that the singularity is your future, unavoidably. And as you get closer, tidal forces begin. If you fell into a stellar mass black hole, one formed from a collapsed star, the gravity difference between your head and your feet would stretch you like spaghetti. Scientists actually call this spaghettification. That's a real term in astrophysics. But fall into a supermassive black hole, something like the one at the center of our own Milky Way galaxy, called Sagittarius A star, which is 4 million times the mass of our sun, and you might survive intact for hours before the tidal forces become lethal. Hours. Inside a black hole, watching the universe outside compress into a single bright ring above you. And then, the singularity. So why does any of this matter? You're sitting wherever you are right now. Maybe it's morning, maybe late at night, and black holes feel like something impossibly far away. But here's the thing. Every discovery about black holes is actually a discovery about the fundamental nature of reality, about what space is, what time is, whether information is permanent or destroyable, whether the universe is ultimately deterministic or not. These are not abstract questions. They are the deepest questions human beings can ask. And the fact that in 2025, we have mathematical frameworks, not science fiction, not speculation, but actual peer-reviewed physics that suggest information survives inside black holes, that tells us something profound. The universe keeps receipts. Everything that has ever existed, every star that exploded and formed the atoms in your body, every ancient civilization lost to time, every signal ever sent into space, in some deep quantum sense, the universe has not forgotten a single bit of it. We started this with a question. What is actually inside a black hole? And the answer, the real answer, the one that took over 100 years of human genius to begin to piece together, is this. Inside a black hole is a place where our physics ends and something deeper begins. Where information doesn't die, it transforms. Where time loses its direction. Where the boundary between what is real and what is mathematical blurs into something we don't yet have words for. We haven't solved it. Not completely. Scientists will be working on this for generations. But we are closer than we have ever been. And I think that's the most human thing about science. It's not about having all the answers. It's about having the courage to keep asking questions that are bigger than you. Questions that are bigger than any single lifetime. Black holes don't scare me anymore. They remind me that the universe is far stranger, far deeper, and far more magnificent than anything our ancestors could have imagined. And we get to live in the age where we're finally starting to see inside them. If this blew your mind even a little, you already know what to do. Subscribe, because we've got more of the universe to explore together. And trust me, it only gets weirder from here.